For the last video for week 15, we're talking about something called the graphing form of quadratics. So this is going to be a very helpful way to write an equation. So in the last lesson, or the first lesson of this week, when we transformed graphs of quadratic functions, we're going to kind of use that idea. But today we're going to learn to change a quadratic equation in standard form, how we've been dealing with it, into this new form called graphing form. So Anessa looked over her work from yesterday and she wrote down the equation g of x, or that could be like y equals x to the third, or x minus 3 quantity squared minus 4, but she cannot find the graph that goes with it. So based on what we discovered from the previous lesson, let's sketch this graph right here. So we know if we have this graph that this 4 on the outside is going to move stuff down 4, and then this 3 with the x, we're going to, remember we mess with the x, so since that's a positive 3, since that's a negative 3, we're going to use the opposite, and we're going to go 1, 2, 3, and we're going to shift it down 4, 1, 2, 3, 4, so 1, 2, 3, 4, so my vertex is right here, and because this is a positive in front, we know it's going to open up, so our graph is something like this. Okay, where is the vertex of that graph? It's 3, 4. And do you see why this is called the graphing form? Because, it's 3, negative 4. 3, negative 4. You see how this is called the graphing form? You see how we can get the numbers for the vertex straight from the equation. We take the opposite of the x. Remember I say you mess with the x. And then you use this number out here. So what's the opposite of negative 3? Positive 3. And there's a minus 4. So our vertex is 3, negative 4. Now how do we find the x-intercepts of this equation? Well, I don't have it graphed perfectly. I just know where the vertex is. So the x-intercepts is when y equals 0, right? So we're going to have x-intercepts where it touches. And then the x-intercepts, y equals 0. And the y-intercepts is where x equals 0. So let's go ahead and this g of x equals x minus 3 squared minus 4. Let's go ahead, this is like our y value. Let's set that equal to 0 and solve for our x-intercepts. You get x minus 3 squared minus 4. I'm going to add 4 to both sides. And we're going to get 4 equals x minus 3 squared. And we know that when we have that term squared, to solve for it, we're going to take the square root of both sides. So we're going to get plus or minus 2 equals x minus 3, because the square and the square root cancel each other out. So we're going to add 3. So we have 3 plus or minus 2. So 3 plus 2, 3 minus 2. Or no, 3 plus 2, 3 minus 2. So we get 5 and 1. And if I look at my graph, oh, I got lucky here. Look at, I crossed at 1. And this is 3, 4, 5. I'll put 5 right here. So these are my y-intercepts, or my x-intercepts. Sorry, my x-intercepts are when we set y equal to 0. So we had 5, 0, and 1, 0. And now to find my y-intercept, I'm going to set x equal to 0. So we're going to get g of x, or y, equals 0 minus 3 squared minus 4. This is negative 3 squared, or negative 3, and then I square it, I get 9, minus 4 equals 5. So my y-intercept is 0, 5. So as we come up here, this number here would be 0, 5. Our y-intercept is 0, 5. All right? So rewrite Anessa's equation in standard form and in factored form. So, okay, so let's see. She has the equation g of x, or I'm just going to change this to y equals x minus 3 squared minus 4. So we want to y equals, this is really x minus 3 times x minus 3 minus 4. And so if I were to use my box to solve this, x minus 3, you're going to get x squared negative 3x, negative 3x, and 9. So that's going to be y equals x squared. Negative 3 and negative 3 is negative 6x minus 9 minus 4. I'm sorry, plus 9 minus 4. And then that simplified, it becomes x squared minus 6x plus 5. So this is standard form. Standard form. In factored form, now I have to use my box in the other direction backwards. X squared 5. So what multiplies to make 5x squared that we can get a negative 6 out of? How about negative 1 times positive 6? No, that's not going to work. It's to multiply to 5. Negative 1 times negative 5. Negative 1 and negative 1 makes positive 5. So negative 1x and negative 5x. So let's go ahead and we get x and x. We're using our box to factor it. This is negative 5. This is negative 1. Negative 1 times 5. Negative 1 times negative 5 is positive 5. So factored form is x minus 1, x minus 5. This is factored form. Never enough room on these papers to write. Okay. Now let's sketch the graph using the information from the factored form part. Well, remember the factored form? So these 1 and negative 1 and 5, you use the opposite, set each of these, x minus 1 equal to 0 and x minus 5 equal to 0, and you solve for x. You get x equals 1, x equals 5. So here are our y-intercepts, 4, 5. Okay, 1, 2, 3, 4 spaces between the two, so halfway is 1, 2. And so that means we know that our vertex lies on the line y or x equals 3. So I would take 3 and plug it into the original equation. The original equation is right here. So I would do x squared minus 6x plus 5 in our standard form. So that's going to be 3 squared minus 6 times 3 plus 5. This makes it 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5 equals negative 4. So I plugged in 3 and I got negative 4, and that's my vertex, 1, 2, 3, on this line. And so that does help us to graph it. But wasn't this nice form that Anessa had it in? From that form right there, I could just pull out the vertex. So it is nice. I can pull out the vertex. I can actually find the x-intercepts by setting y equal to 0. And then I found that we had, where is it, 5 and 1, right here. And those were the x-intercepts. So this is all related to each other. Let's look at the last question here on this page. A function in the form of a times quantity x minus h squared plus k is said to be in graphing form with the locator point hk for a quadratic function. Another name for this is the vertex form. Why is this an appropriate name? Okay, using the graphing form, we can pull the vertex points directly from that form. Okay, so remember Anessa had x minus 3, this is a minus 3 squared minus 4. So this, I can pull the vertex directly from this graphing form. I take the opposite of this, which is a positive 3, and then I just take this number out here, negative 4. And that's a really nice way to grab the vertex. Let's look at this last page, see what you're going to do. Okay. Last semester, you used a process of completing the square to rewrite the quadratic equations in perfect square form. For example, by completing the square, you rewrote x squared plus 4x plus 1 into the perfect square of x squared plus 2 equals 3. This process of completing the square can be used to rewrite the quadratic function. Okay, so if I can put it in graphing form by just moving this 3 over to this other side. So graphing form would be x plus 2 squared minus 3. And from this, I know that the vertex is going to be the opposite of what's in here, -2. And then this -3, -2 minus 3 would be the vertex. Let's do that with these two problems here. Okay, this is what I want to focus on. What is half of 6? 3. 3 squared is 9. So we already have a 9. So this is already in perfect square mode. So we're going to have x plus 3. Because this is a plus, I'm going to keep it a plus, and then I'm going to square it. And then that equals 0. So if I subtract, so this vertex would just be the opposite of what's on the inside. Since we're not adding or subtracting any number, so it's just going to be a 0 because we're not adding or subtracting anything. And this next number here, we already know that we're going to have to add 9 to both sides. So x squared plus 6x plus 9 equals -1. I'm going to add 9 to that side also. So set that equal to 0. I subtracted 1 from both sides. That canceled, and I knew half of 6 is 3. 3 squared is 9, so I'm going to add 9 here. I'm going to add 9 here. We can write this as x plus 3, same setup as the question on the left, squared equals 8. And now if I solve for 0, x plus 3 squared minus 8 equals 0. Now it's in vertex form, and I can get you the vertex or graphing form, and I can grab the vertex out of that, the opposite of what's in the parentheses, and then minus 8. So the vertex is -3, -8. All right, so we reviewed completing the square while you were sinking in about quadratic formulas. So for you tonight, there are 3 problems to rewrite in vertex form or graphing form. Okay, so what you'll have to do is complete the square, right? And then write it in graphic form. And don't use the algebra tiles. And then sketch the parabola. The hint, or like part 3, is going to be find the X intercepts. And you do that by setting y equal to 0. Okay, so do these 3. Graph them here, and also remember you can go to Desmos for help with graphing. All right, I will see you on Zoom.